Students, here we discuss about the circles. This is our chapter 10 for class mathematics. Okay. Now, what is the concept of a circle? Any closed figure, which is equidistant from a fixed point. Okay. This is a closed figure. Okay, closed figure. This is when the part is closed. It is closed figure. And it is closed figure is a combination of infinite number of points, from which point it is equidistant. This point is known as the center. Okay, this is the center, and from the center, if we draw a line segment to the circumference of the circle, this is known as the radius. It is radius. Okay, and if we join any 2 points of the circumference through the center O, suppose it is B, A or B, it is known as diameter. Do you know what is the relation between radius and R is equal to D by 2? This is the relation between radius and diameter. And this is known as chord. Suppose PQ. PQ is a chord. Okay. These are the main parts of the circle. Now, what is a tangent of a circle? If we draw a line segment at a point outside, okay, of the circle, suppose it is a point on the circumference of the circle, and here we draw a line. It is suppose L, okay, and this is known as ST. ST is known as what is tangent. Understand this? It is known as tangent of the circle. Now, what is the name of this point? What is the name of L? L is the point at the tangent of the circle is known as point of contact. It is the point of contact. Okay. PAST is the tangent. And according to theorem 10.1, what is the relation between radius and point of contact? The point of contact is when it is suppose this is, we draw here a circle. I use my bengal. Okay, you use compass. You see what is its name? This is second. When seconds drawn outside, okay, it will touch a point, so it is known as tangent. What is this? It is secant, SECANT. That means a secant may be a tangent, but a tangent may not be a secant. This is the special case of a secant. Okay. And what is the relation between tangent at any point of a circle to the radius? This is circle. It is suppose center. Here you draw a tangent. Okay. This tangent, suppose P. And what is the relation between OP? OP is always perpendicular to the tangent LM, suppose. OP perpendicular to LM. And using this condition, we can do mathematical problems. Now we go to the exercise. Students, we go to exercise now. See in the exercise, number 1, how many tangents can a circle have? Infinitely many. Suppose this is a circle. Here you can draw a tangent here. A circle is a combination of infinite number of points. So we can draw infinite number of tangent. Then question number 2, fill in the blanks. A tangent to a circle intersects it in dash points. Suppose it is tangent, PQ is a tangent. It intersects the circle at most only at a point. So 1 point. Then number 2. A line intersecting circle in 2 points is called secant. Number 3. A circle can have dash parallels. Suppose this is a circle. Okay. Suppose it is diameter. You can draw only 2 parallels. Understand? So we can do only, at most 2 parallels. Okay. A circle has at most 2 parallels. Number 4. The common point of tangent to a circle and the circle is known as point of contact. Then see the question number 3. What is given? The radius of a circle O is given. What is the radius? OP. OP is the radius here because PQ is a tangent. So P is the point of contact. It becomes radius. And what is given? The distance between O and Q is given. The distance between O and Q is 12 centimeter. Now question asks we to find PQ. Now suppose according to theorem 10.1, what we find? OP is perpendicular to PQ. Okay, OP is perpendicular to PQ. So it is a right angle triangle. When we get a right angle triangle, we can apply Pythagoras theorem. What is the Pythagoras theorem? Pythagoras theorem is that the square of the diagonal is equal to the square of the sum of other two sides. So OQ square is equal to OP square plus PQ square. Okay. Now question asks you to find PQ. So PQ is equal to OQ square root over OQ square minus OP square. This is calculation. Now like this we can solve the mathematical problems. Students, how are you? We already learned about the tangents, secant and the point of contact in the exercise 10.1. Today we learned the number of tangents from a point to a circle. See here, P is a point inside the circle. We can draw infinite number of lines through P. Do you know? We can draw infinite number of lines through a point P. If P point goes outside, okay, P is the point on the circle. Here we draw only one line. That line is known as the line of tangent. That is tangent. That means from this we can conclude that at a point of a circle we can draw only one tangent. This is the tangent at the point P. And see here, out of a point P, it is the point outside of the circle. From this point we draw two tangents PT1 and PT2. That means outside of a point we can draw how many tangents? Two tangents. And the distance of these tangents PT1 is always equal to PT2. Okay, students, understand this? And here we get three cases. Number 1 case, there is no tangent to a circle passing through a point lying inside the circle. Do you understand this? When the point is lying inside the circle, we cannot draw a tangent. There is one and only one tangent to a circle passing through a point lying on the circle. This is only one tangent we can draw. Number 3, there are extremely two tangents of a circle through a point lying outside the circle. These are PT1 and P2. T2 are the two tangents where P lies outside the circle. The length of line segment, okay, from the external point P to this PT1. PT1 is known as length of the tangent, and PT2 is also the length of the tangent. And we already, I said already that PT1 is always equal to the T2. See question from 1 to 3. Select the correct option. What is given here? Given a point Q is outside the circle, a distance OQ is given, and distance PQ is also given. Here we write given. And the question asks you to find the radius of the circle. Okay. We already know from theorem 1 that the radius is always perpendicular to the point of contact. So it is perpendicular. Okay. Okay. So we can apply Pythagoras theorem. What is the Pythagoras theorem? The square of diagonal is equal to the sum of the square of the other two sides. Here we are going to find OP. So OP is equal to root over OQ square minus PQ square. Substituting the values, we get 7. Therefore OP is 7. The option A is correct. Then what is the question number 2? In the figure, this is a figure, TP and TQ are the two tangents to the circle with center O, and the angle POQ is given. Now we have to find PTQ. This we know that, but we learn after in the exercise that PTQ and POQ are supplementary angles. Since they are supplementary, their sum is always equal to 180 degree. Therefore, PTQ is equal to 180 minus POQ, 70 degree. So, option 2 is, option B is correct. Then question number 3, what is given? Question number is given 3. If tangents PA and PB from a point P to a circle with center O are inclined to each other at an angle 80 degree, then find POA. Okay. This is the point P. Here P and PB are the tangents. Okay. And the angle between APB, what is given? 80 degree. We know that PA and PB are always equal. So we can prove that angle APO is always equal to PBPO. So the APB is 80 degree. So this angle is 40 degree. This angle is also 40 degree. And again we find already in 10.1 that OA is always perpendicular to PA. So it is 90 degree. We know that the sum of the angles of a triangle is 180 degree. So what values of this angle and this angle we know? We have to find POA. So what is the sum of this and this? 90 plus 40. 90 plus 40 equal to 180. Sum of the angles of a triangle is equal to 180 degree. So from 180 we subtract 130. What is find? 30 degree. So our option is A. Students, do you understand this? If you not understand clearly, please ask me questions.